to use the properties to evaluate, we want to be able to list whatever happens in the equation. So if we look at this equation, we have this 7 times 1, which was 7 times 4 minus 3. So basically, we substituted 1 for the 4 minus 3. So that's the property we used. The next, we look at the next version, and we have 7 times 1 gives us the identity property, because that's how we got 7. 7 times 1 keeps the identity. The next part of the problem we look at is when you take 5 times 1/5, that's its inverse, we have the inverse property. And then the last thing we'd have is substitution, because 7 minus 1 is 6. And then the last one is also substitution, because 6 plus 1 is 7. So I identified the properties going from one equation to the next equation. So now let's do the same thing over here in the guided practice. What's going on in this problem? So if we have this as our original problem, we go from the 4 times 2, so that's the substitution property. And then when we go 8 minus 8, we have the addition property of, I believe it's 0, identity, addition, identity. And then when we take 2, 3 to 6, we do the substitution. And then 6 plus 0 is also the additive identity property. Now, in this case, we have multiplication properties, and they have two of them, the commutative property and the associative. Commutative means to move, and associative means to group. So if we change the movement of where the numbers are located, or we change the group, we have these properties. So let's look at what we have. Here's our original. So we have 5, 7, 4, 2, but then we have 5, 2, 7, 4. So we've moved them around, so this is the commutative property. Now if we go down here and I group the 5, 2 together and the 7, 4, because I'm grouping them, I have what's called the associative property. And then when I substitute 10 for 5 times 2 and 28 for 7 times 4, I have the substitution property. And once again, I have the substitution property because of the multiplication. So let's look at what's going on this other side. I want to be able to write this by changing the order. And sometimes changing the order, that helps us do the problem. Since we have a decimal number, anytime you multiply by 10, so I'm changing the order, that's the commutative. And I'm abbreviating these properties. Then I can group the 2.9 with the 10. The reason is because 10 times 2.9 is going to give us just 29. So that's the substitution property. And if I multiply 29 times 4, I get 76, which is also the substitution property. Not 76, I mean, it's 3, 8, 116. So there's that answer. So let's look at the next problem. I'm going to take the 5/3 and I'm going to group it with the 3, or change, not group it, I'm going to change the order. So that is the commutative property. And then I'm going to group these. I'm going to group, and the reason why I'm grouping them is because they are not inverses, but they have the same denominator and numerator, which will cancel them out. So that's the associative, because I'm going to group the two that work. And then when I cancel out the 3's, I get 5. That's the substitution property. And 25 times 2 gives me 50, so it's also the substitution property. And 50 times 5 is 250. So the substitution property gets used quite often in a lot of these problems because, and I'm circling all of them, because we're constantly changing the math to what it really equals.